So now that we have an attribute selected and a time range prepared, we can get some data for this selected attribute for the desired time range. We were looking briefly earlier at this AF attribute object, and it gives us, among a bunch of properties that we recognize from PySystem Explorer, gives us a few getValue and getValues methods. Now, these are the basic way to get values from an attribute, but later on we'll look at some more specific targeted methods. For now, looks like what we want is to get a collection of AF value objects for an attribute for a given time range. So we'll look at this overload of the getValues method. Sure enough, the first thing it wants is a time range, and I've got one of those. So we'll spin up an AF values collection and start putting this data call together. This AF values collection is something that we'll look at in a little bit after we make the call. We'll need to examine what exactly it contains, but for now, let's continue. We've got a collection of AF values for the selected attribute dot get values. And sure enough, that first overload is what we want. We want values over the given time range, and then number of values. What's that? Within the SDK reference, thankfully, there are notes. Now, this getValues method is a kind of multi-purpose method that can behave in several modes. If we give a negative number of values, it does one thing. If we give it a positive number of values, it does another. Currently, what we want is just all of the recorded values. The general case, so we will say number of values is 0. Of course, we will get more than 0 values, but this just specifies the behavior that we want. So 0, and then the method asks for a desired unit of measure. You might recall that when we configured attributes in PySystem Explorer, every attribute, or at least most of them, have a default unit of measure. So mass share comes back in %, volume comes back in US gallons, which are a type of the volume class, and other attributes that aren't numeric might not have a default unit of measure. But certainly most of these do. So for our method, our data call, let's look at this desired UOM parameter. Turns out that if we return a null for the desired unit of measure, that default from the attribute configuration will be used. So mass share will come back as its default in %. Later, we'll look at requesting values in a certain unit of measure, but for now, we'll just go with this default case. Okay, so now that we have values, the easiest thing to do to see those values is just, for our exercise, dump them into a list box. So we'll make a list box to hold strings of the values. I'll call my list box LB values. Okay. So back in the code, we will populate the list box. Our AF values collection, if we take a look at it in the help, is in fact a list of AF value objects. So we can treat it just like the generic collection it is. For each AF value object, we'll take that value and hammer it into a string. .NET includes a pretty helpful method, the static string.format method, which, if you haven't seen that, you might want to pause this video and go look at the MSDN docs on that. It's a useful little method. It'll let us take several parameters like the timestamp and the actual value and its unit of measure and run them all together pretty easily. Alternatively, if you're more comfortable using something like string.concat, you're welcome to just do a simple concatenation as well. So I'll say that for my string representation of the AF value, I'm really interested in seeing the timestamp and the actual value and what unit of measure it's in. Alright, so let's look at this AF value object. In fact, a lot of the properties on this, if you're familiar with Pi in general, you'll see some familiar properties. In Pi, events are defined largely by their timestamp and their value. Of course, what PiAF brings to the table is some additional things like the unit of measure. One attribute, one property here that deserves mention is the isGood property. In Pi, a value being good means that the value is of the expected data type. That's all it means. Either it is good and it has a valid value in the type that we're expecting, or it has pretty much an invalid state associated with it. Now, that's a topic that deserves its own little video, but for now, the important thing is that if a value is good, we can trust that that value is of a data type that we're expecting. Now, as for what data type we're expecting, it's actually a property of the attribute. Makes sense. Remember in PySystem Explorer when we configured the attribute? It has a value type associated with it. Every attribute has a value type. Well, that's accessible in the SDK. We know what data type we're expecting from our attribute. Selected attribute dot type tells us the type of data that this thing should give us. So if we are expecting numeric values and we want to cast them, well, we can check what type the attribute is configured to give, and for any value that is good, then we know the value is useful in the expected data type. Okay, but for now, let's see. The first thing we want in our formatted string, I want to show the timestamp, the value, and the unit of measure. So, my AF value has a timestamp, which is an AF time object that we've seen. And of course we can take that AF time object and in turn ask for it in various formats, specifically in local time, etc. The next thing I want to show is actually the value. So the AF value dot value will actually give us the value object. Remember, that's what the isGood property tells us, if this will be in the attributes data type. Now we want to show the unit of measure. So value dot UOM. If we look at this unit of measure data type, it's actually a data type unit of measure. It has some properties that we recognize, especially if we're well acquainted with units of measure in Pi as a framework. There's one here that looks good, abbreviation. And in fact, in PySystem Explorer, we can see that every data type, every unit of measure has an abbreviation. So maybe that's a friendlier thing to show here on our screen. We'll go with that. Great. So we have our string, and we will stuff it into the list box of values. see if our code works. So I pick one of my tanks and get some values for its level. Sure enough, look at that, our data call works. Within that time range, I'm getting values. Alright, so we know that level comes from a pi tag. What if we pick something that's pretty much the result of some calculations, like mass? We'll try that. Get the data again, and sure enough, we have mass values. What about something that's a constant like capacity? Get data. Sure enough, we have capacity interpolated at right now and exactly 3 hours ago. Thankfully, capacity has not changed. So the final test here, let's look at our material. When we hit the Get Data button, something unhappy occurs. We get some big yellow highlighting. What's wrong? We recall that just about all of our attributes had a unit of measure associated with them. They're numeric, we can do that. But material, in fact, is non-numeric. It's that enumeration set. So like anything that's not numeric, it really can't have a unit of measure. Which means we go back to the mantra of always expecting the null case in the AF SDK. Here, our unit of measure is null for the material attribute, so we need to handle that. If the unit of measure is not null, then we can show its abbreviation, otherwise don't show anything at all. Let's try this and see if it works better. Sure enough, there it is. We have values for the given time range with a unit of measure, if appropriate. Next, we will look at allowing the user to specify which unit of measure they would like the values in.